Hi everyone, my name is Martin. I'm going to talk about our work on OSNAP, a fabrication pipeline to magnetically connect conventional and 3D printed electronics. I did this work with my co-authors Jan, Florian, Steffen and Max. So in this talk I'm going to talk about a tedious aspect of 3D printed electronics that is sadly often ignored but very important. One of the main motivations for this paper is the fact that it is often rather easy to 3D print a certain sensor very accurately and precise, but at the same time connecting the printed object into some external sensing electronics includes gluing or some kind of soldering, which does not work so well for 3D printed plastic. Especially in rapid prototyping, this is time-consuming and unnecessary work. This issue even gets worse as sensors are getting more complex, which requires more wires to connect. I think we can all agree that connecting 3D printed sensors to conventional electronics is tedious and no fun at all. So we thought, why isn't it as easy as just snapping two magnetic parts together for a robust connection? And that's exactly what this paper is all about. Say we want to make a car model interactive. Research proposed many approaches that investigate how to integrate such sensing into 3D printed objects, involving different types and shapes of electronics or automatically creating wires and so on. It's basically a solved problem. But most research does not focus on the interface between the 3D printed part and the conventional electronics at all, leaving out how to robustly and easily connect both kinds of electronics. We tackle this problem by printing a ferromagnetic conductive port into the object to which all wiring is routed to. This port serves as a dock for a magnetic electronics board that contains all the necessary standard electronics required for the object to get fully interactive. We use Puro pins to level out small imperfections of the printed object, which ensures a solid electrical connection. As this approach requires 3 different materials, which is complicated to handle manually for non-experts, we also contribute a fabrication pipeline that helps users in designing snappable objects for capacitive sensing. Users start by loading a 3D printable model into the design tool. They then add capacitive sensors with different tools to the 3D model, add the magnetic port, and let the tool do the wiring. After export, the object can be directly printed on a standard multi-material printer. The object can then be snapped to a conventional electronics board and directly used. As a proof of concept, we contribute a snappable electronics board for capacitive sensing that is smaller than a standard credit card. It features 12 independent capacitive sensing channels, can communicate over Wi-Fi and Bluetooth, and has a battery on board, so it's fully wireless. Capacitive data can be viewed, received and processed through a web interface, WebSocket or MQTT. We evaluated our approach by letting users snap the board to different objects. The evaluation shows that the electrical connection through the pogo pins is well suited for capacitive sensing, and also the snapping is independent of a certain user and robust throughout multiple cycles of attachment. All users reported a sufficient and strong adhesion after snapping. For more details, please see the paper here. While originally created to enrich rapid prototyping, our snap of course can be used in many applications that benefit from a rapid attachment or loosening of electronics from objects with embedded printed sensors. Thanks for watching. If you have any questions, feel free to contact me.